Welcome to the AP Physics Workbook solution. Here we have Unit 4, Work and Energy. This section is 4.B, Choosing the System. So scenario, a ball falls from rest from a height h. Consider the ball to be the system. Part A is to draw a dot circles around the system. This is the ball. This is going to be the system. Part B. The dot at the right represents the ball. You're going to draw a free body diagram showing and labeling the forces exerted on the ball of the system. We know that there's a force pulling it down, which is going to be the force of gravity. On the grid on the right now, we are going to draw the external forces acting on it as a function of height. The force is constant because it's force of gravity, and that value is never going to change. It's always going to be defined as mass times gravity, which is the acceleration in the vertical. Part C. Now they're going to ask, in regards to the area under the curve, what does this area under the curve look like? Please understand that the units for the force is in newtons. The height is going to be in meters. The area under the curve is going to be represented by this. So this is going to be when newtons is going to be multiplied by the meter, which is going to be considered as joules. The x-axis unit is meters and the y-axis is in newtons. The arrow in the curve would be the area. That is Newton meter. That represents the work done by the system, which is called joules. Consider the ball as the system. The work done is the ball's change in kinetic energy, because we know that the work can be defined as the change in kinetic energy, which is just KE final minus KE initial. Mathematically, it looks like 1/2 mv squared final minus 1/2 mv squared initial. You're going to fill in this chart to describe the energy of the system as the ball is being dropped. It's going to start up here by the work done by the system, by gravity. And then it's all going to get converted down to kinetic energy. Make sure it's the same length. Note that the potential energy of the system here is 0 because the Earth is not included in the system. The mechanical energy of the system is increasing right here. Notice it's going up. The chart shows here that there was no kinetic energy at the start, but at the end it had all kinetic energy, because during of that there was work being done into the system. Now, part E. Does mechanical energy increase or decrease or stay the same as the ball fall for a height of h? Justify your answer in part D. I'm just going to bring my answer that I have from above down here because it explains the same thing. The mechanical energy of the system in total is not changing. The bar here is the same thing as the bar here. They're the same length, right? It just got transferred from the work energy being done to the system, equaling to the kinetic energy of the system. Next, if the system was to include Earth, how would the chart of the energy chart change? The chart had it was work external before, but now it is now going to be gravitational potential. That same that same area under the curve is now going to be translated into the kinetic energy here. what is happening in the change is that it's going from the gravitational potential, it's all getting converted to the kinetic energy. I wrote for the answer. Now that the Earth is part of the system, we can include the potential energy, which the system can now describe to have gravitational potential energy, which is U equals to mgh. At the start, the system had all gravitational potential energy, and as it falls, the potential energy is converted to the kinetic energy. All the potential here is converted to the kinetic energy there. Notice there's no more bar for the work external right here. There's no bar here because the Earth is now part of the system. That's why the bar was removed here and now goes into the UGH column. There's no more external force that is doing work on the system because now the Earth is part of the system. And the last part, I have the answer down here for us. It asks, if the system were to include Earth, would the mechanical energy increase, decrease, or stay the same? Notice that the bar initial is the same thing as the bar final here. Same thing here. The initial bar here is equal to the final bar here. This is when it was just a ball. This is ball and Earth. Notice that the area under the curve initial is the same thing as the area under the curve final. Same thing here and same thing here. With the system being Earth and ball, the total mechanical energy is the same amount as before. The addition of the Earth into the system cannot add energy or reduce energy because energy was never created nor destroyed. It was just transferred, the law of thermodynamics. How it was transferred is that the work energy column here, bar, was transferred to the potential energy column when the Earth was introduced into the system. Likewise, if we took the Earth out of the system, then this bar would now be removed and it would go to the work energy. So it would look like this. So this is with Earth. This is without Earth. It would go here. Okay. Now I just would like to give you just a couple of notes and references to potential energy. Potential energy is the energy associated with the force that depends on the position or configuration of the object related to its surroundings. The most common one is the gravitational potential energy. A heavy brick held above the ground has potential energy because of its position relative to the Earth. The rise brick has the ability to do work, for if it is released, it will fall to the ground due to the gravitational force and can do work, say diving into the ground. Force falling down and it's traveling a distance, that is the work done. Thus, to raise an object to mass to the height to do work, that is defined as the mgh. At height h, the object has the ability to do work onto the amount of work equally mgh. Therefore, we could define the gravitational potential energy of a system due to the Earth's gravity as potential energy mgy. You might also see this as mgh. A couple something interesting about the potential energy and work. The change in the potential energy is considered negative work, and the negative just means its direction. Okay, it's the work done by the external force. That is, the change in the gravitational potential energy as the object moves from position 1 to position 2 is equal to the negative of the work done by gravity by itself. It's the negative of the work done by gravity of itself because the energy is the work is negative because the gravitational potential energy is increasing. The gravitational energy depends on the vertical height of the object above some reference level. Okay, so here you go. These are all your notes. Here's your solutions, and here are your notes. Okay, and this is for 4.B.